Good morning, and let's get started on a new topic. We're going to be talking about matrices. And so let's just jump in with a definition of what a matrix is. And before I give you the full definition, I think of a matrix as an Excel spreadsheet. So if you kind of keep that in mind when we're doing this, I think that might help you out a little bit. But a matrix is simply a rectangular array of variables or constants in rows or columns, or rows and columns, it should say, usually enclosed in brackets. So let me go ahead and get that down. So it is a rectangular array of variables or constants in rows and columns. And they're usually enclosed in brackets. Okay, and so here's an example over to the side, and you can see again the brackets that we're talking about here. Okay, so your brackets. Sorry, my computer's not working. There we go. So these are what we're talking about with the brackets, usually around matrix. And the other thing is they're in rows and columns. So let's also look at that piece of it. So these would be our rows. Okay, so rows are purple. And then our columns are going down. Okay, those are our columns. So think about the columns like in the Roman Colosseums, and you've got the big columns. That's what we're talking about there. Okay, and then rows. Okay, so don't confuse those two as to which is rows and which is columns. So again, rows are down, columns are down, rows are across. Okay, the next word that we're going to look at is the elements. What are the elements? Well, the elements are the numbers like the 3, the 6, the 24. Those are the elements of. And so it is, elements are the individual values within the matrix. Okay, so each individual, so a -3 would be an element, 6 would be an element, 24 is an element. And so when we do elements on there, the way that we write those is we will write A, I'll call that use that as your letter. And then what we do is an X, Y. Okay, so it's rows by columns is how we'll write that. Okay, is used to denote each element where X is the rows number and the Y is the column number. Okay, where the element is located. So here's some examples down here below. If you have A25, now that doesn't mean 25, and what you'll see me do a lot, I'm really bad about, because I think it makes more sense to me, I put a comma between it. Technically there's no comma there, it's just 2 and 5. So that would mean row 2, column 5. Okay, so row 2, so this would be row 1, row 2, row 3. This is column 1, column 2, column 3, so forth. So we're in row 2, okay, column 5, 1, 2, 3, 4, 5. And -2 would be and we call that, guys, we call this the entry. Okay, okay. So when we say what is the entry, that -2 would be the entry. Okay, kind of another word for element. Okay, so 3, 1. So 3, 1 would be the number 5. So look up and find 1, 2. And you should have said 40. Try 3, 4. $52. 1, 5. 21. And 2, 2. Is 32. Okay, so make sure again that you can understand how to find each of the different entries, the elements that are there. Also, just a real quick side note over here on, and you'll notice over here on the side, matrices are named using capital letters. So when they say A, okay, so you'll see something like A plus B. They're meaning take matrix A and add it to matrix B. Okay, so just so that you're aware of that, it's always a capital letter. The element or the entry is a small letter. Okay, so let's move on. We're going to talk about dimensions. How do we know what the dimensions are of a matrix? Okay, and the way that we note the dimensions, okay, it is M rows by N columns. And you'll see it written a lot as just M times N. So very similar if you know anything about wood. You know, when we say we've got a 2x4 board and they write it as a 2x4 that way, and that's exactly the way it is here. Okay, an M by N. So rows by columns. So let's just go through number 7 and let's write its dimensions. So how many rows? Remember, rows are going across. So there's one row, there's 3 columns. So this would be a 1 by 3. This one, again, this would be row 1, row 2, row 3, row 4, column 1, column 2. So this would be a 4 by 2. I'll give you a minute. Try number 9 and see what you get. It's a 3 by 4. Try number 10. And it is a 2 by 6. Okay, and finding the dimensions is going to come in handy later on when we start multiplying. You're going to need to know those. Okay, so let's talk about what are equal matrices. So two matrices in which each element in one matrix is equal to the corresponding element in the other matrix. So let's get that written down. So two matrices in which each element in one matrix is equal to the corresponding element in the other matrix. Run them out of room here. Okay. So an example to that, and they didn't leave a spot for that, so I'm going to come up here with the dimensions piece of it and do an example. Okay. So if we say that two matrices are equal, and let's say that this is 1, and then we'll call that B, C, and 3, and we'll call this over here A, 4, -2, D. And I ask you to tell me what is A, B, C, and D. Well, what that means is that corresponding positions are the same. So in this case, I would know that A was 1, okay? And then B would be 4, because those are in corresponding positions. They're both in the 2-2 position. So B would be 4. And then when I go and I do C, corresponding positions, so C would be a -2. And then again, final corresponding position, D would be 3. Okay? Now, what you'll see sometimes is they will give you, make it a little bit more difficult in the fact that they'll say something like x plus 3, and then they'll put a 5 here. And then that way you have to write an equation for it, because you know that in this case, x plus 3 would have to equal 5, just to make it a little bit more difficult for you. Okay, so let's go on then to a few more vocabulary words. So we're going to talk about the special matrix, and some of these are more important as far as memorizing than others. So let's just go ahead and get started. So when we talk about a row matrix, it is simply just a matrix that has a single row. So it might be something that looks like A, B, and C. Okay, it just has a single row. Or if it had numbers in it, it could be like 1, -1, 0. Okay? The column matrix is just the opposite. Of course, it is a column, X, Y, Z, and when we're doing 3x3s, you'll see us use a column matrix. So an example would be like 1, -1, 3. Okay. When we have a square matrix, what a square matrix is exactly what it sounds like. It is rows by columns the exact same dimensions. So it would be like a 2x2, a 3x3, 4x4. Where you're going to see those is again when we're solving our systems and we're talking about 2x2s or 3x3s, just like what we did when we did our systems of equations. And so again, example here might be 4, 9, -3, 5. Okay? The next one that we're going to have is what's called the zero matrix. We actually don't use this one very often, but it's simply a matrix in which it is full of zeros. Okay, we do have a couple other matrices that we'll talk about coming up, but these are the special ones that we talk about right now. Okay, so I'm going to stop this video. It's getting a little long, and then we will continue in just a minute.